Hello students, this is Mr. Boyd. In this video, we're going to take a look at the solutions to last Friday, September 23rd's quiz to review for our Module 1 test. So let's go ahead and jump right in. Looking at number 1, I see that I have a product raised to a power. So what that means is that each thing inside the parentheses is going to get raised to the fourth power. So that means x to the first power gets raised to the fourth power, and y to the second gets raised to the fourth power. So our final answer would be, and then we need to multiply those powers just to review. So our final answer should be x to the fourth, y to the eighth power. All right, let's move on down to number 2. So number 2 is parentheses -3, x to the fourth, y to the fifth, all raised to the second power. So that means that the -3 is getting raised to the second power. The x to the fourth is getting raised to the second power, and the y to the fifth is getting raised to the second power. And of course, our rule is to multiply the exponents. The -3 to the second power would be +9. X to the fourth times 2 would be our x base. Y to the fifth times 2 would be our y base. So the final answer should be 9x to the 8th power, y to the 10th power. Okay, we're going to move on down to number 3 now, which is a very similar problem, except instead of just a product, it's a quotient, but we still follow the same set of rules. So what I see here is that I have a 2x raised to the third power over a y to the second raised to the third power, which then means we have a 2 raised to the third power and an x raised to the third power over a y to the 2 times 3 power, which will then finish up 2 to the third power is 2 times 2 times 2, which gives us 8x to the third power over y to the sixth power. Okay, I see number 4 is a product of two scientific notation numbers. So that means that I'm going to rearrange this problem and put my decimal numbers together. Okay, I'll go ahead and do my power of 10 first. 10 to the 6th times 10 to the 5th. I'm going to add those two powers together, which is going to give me a 10 to the 11th power. And we'll grab my calculator. And I'm going to do 9.4 times 3.2. It's going to give me 30.08. Okay, I see that number is not in scientific notation, so I'm going to need to move that decimal over one more place to put it in scientific notation. For a number to be in scientific notation, that first number needs to be between 1 and 10. So this would give us 3.008 times 10 to the 12th power, because when I move it one more to the left, I had to add 1 to the power. And so I see that is the answer right there. Okay. So I'll do number 5 down here. So number 5 is a division problem. which is 6.9 times 10 to the 7th, and I'm going to write it using the big fraction bar instead of that slash, divided by 2.3 times 10 to the negative third power. So first thing I see that we're going to do is we're going to do 6.9 divided by 2.3, and we're going to do 10 to the 7th divided by 10 to the negative third. Again, I'm just grouping my like stuff together. So 6.9 divided by 2.3 is 3. And when we handle these powers, because we're dividing like bases, we're going to subtract those two powers. We have a minus, so that's going to change to plus a positive. So that means our final answer is 3 times 10 to the 10th power. And that was that one right there. All right, let's move on to number 6. So for number 6, I see that we're adding two scientific notation numbers. The first rule is that we have to have these powers the same. I'm going to take the second one and I'm going to make it a 7th power. So to do that, I'm going to need to add 3 to this power of 10, which means I need to move that decimal 1, 2, 3 places to the left. Moving to the left increases the power. Okay, so now I can line them up and add them. So now I've got 5.2 times 10 to the 7th. I've got 0.00301 times 10 to the 7th. And I'm going to add those numbers together. So let's see, if I follow along here, it looks like we're going to have 5.20301 times 10 to the 7th power, which would be this answer right here. Last thing you have to do when you get to the end here is check to see if they're in scientific notation. But most of the time, if you use the larger power, it will finish up being in scientific notation and you will not have to change it to scientific notation. So a quick review of standard form. We talked about this earlier in the week last week. Standard form is a number without exponents. So if we take negative 5.6 times 10 to the negative 3, and we put it in standard form, we would need to move this decimal 1, 2, 3 places to the left. And we would stick some zeros in there for placeholders. Moving the decimal does not affect whether it's positive or negative. So negative 0.0056 is the correct answer. Which of the following is correct scientific notation? Well, as we've said before, the first number has to be between 1 and 10. So the only number between 1 and 10 is this answer here. And this answer we're going to change from standard form to scientific notation, 0.0000398. We would move that decimal 1, 2, 3, 4 places to the right. That would give us 3.98 times 10. I moved it to the right 4 places. That would be a negative 4 because this is a little bitty number, which takes a negative power of 10. And our last question is a subtraction question. Again, I'm going to choose the higher power to change my powers. Both powers have to be the same in addition and subtraction. So let me take 1.9 times 10 to the second. I need to add 1. So that means I'm going to move to the left 1. So now I've got 2 times 10 to the third minus 0.19 times 10 to the third. We keep the power of 10. And then when we subtract, we can do this on our calculator. Don't have to do this long division, or long subtraction, you certainly can. 2 minus 0.19 is 1.81. So 1.81 times 10 to the third would be our final answer here. And that concludes our demonstration of the solutions. Guys, I hope you're studying for tomorrow's Module 1 test. Thanks for watching.